Despite the recent paucity of hubs, SpaceX Starbase is a hive of activity, with preparations underway for both the forthcoming orbital test flights of Booster 4 and Ship 20, as well as potential increase in launch cadence with follow-on vehicles. Hey guys, hello everyone and welcome back to Engine Nations. We'll discuss SpaceX finally launching their new Starship to orbit in 2021. But first, subscribe to our channel and click the bell so that you don't miss any videos from us. The majority of recent attentions has been focused on the orbital launch site, notably the tank farm and the Mechazilla modifications to the launch tower. Ship 20, on the other hand, is keeping the suborbital pad occupied with an initial salvo of testing that has begun. SpaceX is currently working towards a November readiness deadline for the orbital flight test, which is still subject to approval from the paperwork side. The FAA's recently published draft Programmatic environmental assessments, which solicited public comments prior to the flight of Booster 4 and Ship 20, highlighted the requirements that must be approved for the historic first push to orbit of the world's most powerful rocket. For the first time, SpaceX put the first orbital-class starships, dubbed Ship 20, through a normal cryogenic proof test, fueling the rocket with hundreds of tons of liquid nitrogen to replicate its explosive propellant. While it is impossible to draw conclusions until members of the public returns to the pad to snap photos or CEO Elon Musk turns to Twitter to discuss the results, Ship 20's first cryo proof appears to have been mainly successful. Musk has confirmed that the test was successful. However, in comparison to the over 3 dozen cryo proof SpaceX has accomplished with more than a dozen other Starships, booster, and test tank prototypes over the last 2 years, Ship 20's first significant test has several anomalies. Every cryo proof of a full Starship prototype has been visually unique and visually impossible to predict in the past, without any direct insight from SpaceX or Elon Musk on the objectives, plans, or timeline of the test. The process of watching tests and attempting to interpret why certain things looks the way they do or what's going on at any given moment is akin to attempting to decipher eroded hieroglyphics. Cryogenic tanking tests, whether with Starship, Super Heavy, or test tank with liquid oxygens, methane propellants, or neutral liquid nitrogen, are fairly straightforward at their most basic. The vehicle is connected to pad systems, turned on and partially or completely loaded with cryogenic fluids. The vehicle is detanked once the necessary test objectives have been met or attempted. Starships are filled with swiftly chilled, thin steel tanks, storing them because they are extremely cold, minus 160 to minus 200 degrees Celsius, minus 260 to minus 330 Fahrenheit. Without any insulations, the supercooled steel then freezes water vapor from the humid South Texas air, forming a coating of frost or ice that normally follows the levels of the cryogenic filled liquids in the Starship's tank. Throughout the process, those cryogenic liquids will inevitably come into contact with ambient temperature Starship tanks and plumbing, which are white hot in comparisons and warm up, boiling out into gas. Because a gaseous chemical is significantly less dense than its liquid counterpart, the pressure inside the Starship's permanent tanks can quickly become unmanageable after even a minor quantity of boil-off. To maintain proper tank pressure, the Starships, like all other rockets, fans off the gas that builds on occasions. As a result, the two primary means of analysis for hieroglyphics are cryoproof testing and frost levels and venting. In comparison to previous prototypes, Starship's S-20 initial cryoproof has been hot, most significantly at about 8 p.m. CDT. SpaceX began loading the rocket with liquid nitrogen. Over the next hour, its LOX and CH4 tanks were gradually filled to approximately 30 to 50% of their full capacity. Rather than detanking, SpaceX then partially drained the methane tank and filled the LOX tank even more, leaving the LOX tank nearly full for more than 2 hours, occasionally topping it off with more liquid nitrogen. Then over 4 hours after the LN2 loading began, the Starship performed a series of huge vents. Given the hours of testing prior, those vents would almost certainly have been detank vents, effectively depressurizing the Starship's tank as they were drained of fluid. Those vents, however, corresponded with the rapid loading of 1 or several hundred tons of LN2, effectively topping off Starship S-20. Around that time, it's conceivable that SpaceX began the pressure testing component of Ship 20's cryoproof largely by clocking the rocket's fans and progressively increasing the pressure to flight levels, if not higher. Several months ago, Musk stated an operating pressure objective of 6 bar several months ago, when SpaceX was deep into cryoproofing the first full-size Starship prototypes. Ships were eventually tested at pressures greater than 8 bar, giving Starship a comfortable 30% safety margin. Ship 20, as the first orbital-class Starship prototype, will most likely need to hit those tank pressures harder than any ship before it in order to survive its orbital launch debut and orbital velocity descent attempt. Beyond the fundamentals of cryoproofing, Starship's S-20 made history on September 29th and 30th by being the first ship to complete a cryoproof test with a full heat shield mounted. While it's impossible to say how effectively S-20's 15,000 tile while heat shield fared. Picture from public cameras showed no clear signs of tiles fracturing and coming off as the Starship cooled and warmed repeatedly, shrinking and expanding as a result. Furthermore, if the steel tank skin behind the majority of Ship 20 tiles had remained in contact with the air, it would have likely converted itself in a coating of frost and ice. Yet the heat shield appeared to handle that unseen shift without trouble. It's possible that dozens or hundreds of tiles collided and chipped or cracked in a way that was too subtle to be seen on Lab Padre or NASA spaceflight webcasts. However, it can only be confirmed or rejected after the road reopens and local photographers are able to obtain higher resolution images of the Starship. For the time being, it appears that Ship 20's first cryoproof was a huge success, paving way for Raptor installations and static fire testing in the near future. Elon Musk, CEO of SpaceX, didn't waste any time in tweeting about the findings of Starship S20's first cryoproof, stating that the proof was good. SpaceX may now move on to testing the Raptor engines on the Starship SN20. The spacecraft prototype will be outfitted with 6 engines, 3 of which are vacuum-optimized Raptors with a bigger nozzle specifically intended for space propulsion. The Super Heavy Booster 4 will be equipped with 29 Raptor engines optimized for atmospheric flight. Booster 4 will be subjected to one-on-one testing program. The first will be a set of proof tests comparable to the SN20, followed by a static fire test of the powerful engines. It will be the company's first launch of a rocket powered by 29 Raptor engines. SpaceX created and built the engines, which are novel to the aerospace industry. Unlike ordinary rocket engines, which run on rocket-grade kerosene, Raptor engines run on liquid methane and liquid oxygens, commonly known as methalox. Each Raptor engines can produce around 185 tons of thrust. Musk previously stated that the goal for future Raptor engine productions is to raise the thrust from 185 tons to 230 tons. Once operational, the Super Heavy rocket will be the world's most powerful launch vehicle. At the Starbase, you may observe SpaceX operations. The Starship spaceship, which is 15 meters tall, is linked to the top of the launcher. The closest estimate of the dry mass of the Starship is less than 100 tons. The spaceship has propellant capacity of 1,200 tons, which is divided between 2 mains and 2 header tanks. 1 main and 1 header tank are filled with liquid oxygens, while the other 2 are filled with liquid methane. The liquid methane header tank is located between the 2 main tanks, whereas the liquid oxygen header tank is located on the nose cone. The fuel required to flip and land the spaceship is stored in header tanks. 6 Raptors are installed on its underside. 3 of them are designed to operate in the atmosphere, while the other 3 are Raptor vacuum. The spacecraft's falling, velocity, and orientations are controlled by 4 body flaps. 2 forward flaps are attached to the nose cone, while 2 aft flaps are attached to the bottom. The heat shield on the Starship is composed of thousands of black ceramic tiles that are fastened to the hull using mounting pins with a thermal blanket underneath. The tiles are primarily hexagonal and spaced to allow for thermal expansions. There will be no launch escape system. The storage volume of the Starship is planned to be 1,100 meter cubic, significantly greater than that of any other spaceship. The pressurized space on the Apollo command and service modules is less than 1% of its total volume, with 8.95 meter cubic available. During liftoff, the spacecraft is predicted to undergo roughly 2g of side and downward accelerations, as well as up to 6g of upward accelerations. During Starship's liftoff and transonic flight, the payload area experiences a maximum overall sound pressure level of roughly 135 decibel, which is lower than the Space Shuttle's 142 decibel. A landing may yield more than 60 decibel of A-weighted noise as perceived in Brownsville, which is comparable to the noise intensity of a super heavy landing but significantly lower than vehicle liftoff. That's all we have for today. Thank you for stopping by to watch the video. If you liked it, please share and subscribe to our channel so that you can see more excellent films like this in the future. Everyone,